All right, to conclude section 2 of chapter 2, we're going to look at how you locate the epicenter. This is actually pretty easily done through a process we call triangulation. Triangulation sounds a lot more difficult than what it actually is, but what scientists do is they actually measure the time between P waves and S waves. Remember, P waves are your longitudinal compression waves, and S waves are your transverse waves. So we can detect the difference between them, and we measure the time it takes for us to pick up our first S waves after we have noticed a P wave. Once we get that time, we can actually get a distance. So I can use this distance and say, hey, the earthquake happened so many miles from my seismograph. And this distance is actually the radius of a circle I draw with the center of my seismograph and the radius of the circle. I can draw the rest of the circle and say, hey, I know this earthquake happened somewhere along this line, and this line is a circle around the seismograph at a certain distance away from that seismograph. Problem is, I just don't know what direction the earthquake happened in. So what I'm going to need to do is I'm actually going to need to make 3 of those circles. So in order to make 3 circles, I need 3 centers, which means I need 3 different seismographs. So if we look at this little map right here, we have 3 different circles from 3 different seismographs. Our first seismograph, we can say, is right here. It picked up S waves after it picked up P waves, and it said that, hey, my earthquake happened 1,800 kilometers away. So I look on my map, I measure 1,800 kilometers away from it, and I draw a circle around it and say, hey, somewhere on this circle, on this line in our map, our earthquake happened. It could be over here, it could be over here, it could be down there. I don't know. It's happened on this circle, which is 1,800 kilometers away. Well, I do the same thing with the next one. So let's say our next seismograph is in Houston here, and it's going to pick up the same earthquake, only it's only 800 kilometers away from this seismograph. So make the radius 800 kilometers long and draw the circle. So it has to happen in here. Now with just those 2 seismographs, I know they both have to go on the circle that they drew. That leaves this point here and this point here as possible locations for my epicenter. So 2 seismographs, you can narrow down for the whole world, as long as both of them picked up on the earthquake, to 2 possible locations for it. You throw in a third, again you get that circle. All 3 of these circles are only going to meet at 1 point. And in that case, that would be your epicenter right there. So you need to triangulate it. And use it by 3 seismographs. I slipped up and said satellites there, because this is actually how your GPS systems work too. Your GPS systems will receive a satellite image from one of 3 satellites, and each satellite will put you on a line saying, hey, you're so far away from me, hey, you're so far away from me, and you're so far away from me. And wherever all 3 of those satellites meet is where your actual location is, and that's how GPS works. So you do need 3 satellites for that, just like you need 3 seismographs for locating the epicenter of earthquakes.